Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to have a look at the solution to the binomial theorem lesson 4 assignment. And as you have on your screens, okay, this was the assignment. Okay, so let me quickly pick the laser. Okay, this was the assignment. Okay, so this is it. You are asked to expand 1 over root of 1 minus 2x in ascending powers of x up to and including the term in x to the power 4. So I've told you, okay, anytime you read questions, in a quest to protect our marks, let's endeavor to underline the salient part. So we are supposed to have the expansion in ascending powers of x. Okay, and also up to and including the term in x to the power 4. Okay, so this is trying to tell us the way that our terms must be arranged. It must be arranged in ascending powers. So moving in this direction, the powers of the x should be increasing. And this one is also trying to tell us that we need to expand up to a particular term, not all the terms. And the term that we are supposed to expand up to will be s to the power 4. Okay, so please, I'm going to take you through the solution as you were told earlier. Okay, and I will address all your concerns, especially the major ones that came to bear in your various submissions. Okay, so stick and stay with me whilst I do that. Okay, so with this one, I've told you that anytime you read question and you underline the salient part, the first thing that you write is solution. Okay, so let me go for the laser again. So solution, that's the first thing that you write. After you have written the solution, what do you write? You write the question number. That is if the question comes with a number. But here you can obviously see that the question does not come with a number. So you cannot number what your solution. Immediately you number, sorry, immediately you number your solution, it will be M0, A0. So B0, M0, A0. Take note. Okay, you must always number precisely. And here it didn't come with a number. So if you were one of those students who did that, you are supposed to, okay, do mark M0, A0. So it means you are going to get 0 over, okay, over 10. Okay, so you are supposed to wait for us. So just listen at this point. So you are through with your marking. Take note because I've said it times without numbers that you should always learn to number your solution appropriately. So after that, what do we have to do? Okay, we are asked to expand this. Okay, and it's a binomial expression, only that your binomial expression is in the denominator. And always we expand when the expression is in the numerator. So let's see if we can transform this as your rough work. If you are not matured, you can come and do this as a rough work. We know that 1 over root of that will be the same as 1 minus 2 to the power, okay, half. Okay, remember we have to do this because we should, whenever we are expanding our binomial, each exponent must be explicit, must be very clear. Here it wasn't clear. But in the same way, your binomial shouldn't be a denominator, it should be a numerator. So if you bring it up, we are going to get 1 minus 2x all to the power minus 1 on 2. Remember, 1 over a to the power n in indices is equal to a to the power negative what? N. Take note of that. So if this happens to be your rough work, don't forget to cancel either now or in the short word future. All right, so at this point, immediately you do this. This is what you need to do at this point. So now we are going to have, okay, we know before we can expand this, okay, let me see. My exponent is not a positive integer. Okay, so this tells me that I cannot use the combination. Quote the combination, okay, formula in terms of the binomial theorem. I have to use the expanded version. Okay, again, because my first term of my binomial is 1, I thank God, though I'm going to quote the expanded version, okay, of the binomial theorem. I'll quote the one, the special one, the one whose first term will be 1. So I will rather come and quote this. I'll write but, then I come and quote the formula, which we are all familiar. Okay, so the expanded version, the special one, the first term one. So if you do that, you can obviously, once you quote it, it is B2. Okay, we give B marks for you extracting, okay, and quoting formulas diagram. So it will be B2. So 2 marks for that. Okay, after quoting the formula, okay, please take note, you quote the formula and let the formula guide you. So once you quoted the formula, parameters in the formula, in this particular formula will be n and what, and x. Okay, so we have to go and compare and come and substitute these what parameters. So if you compare this binomial to this power and this binomial to this power, you can obviously see that the first terms are the same. So it means I'm going to get my n, also as your rough work, n will be equal to minus half, and your x, will be equal to, your new x will be minus 2x. So take note, it will not be 2x. Those of you who substituted, I thought we've gone beyond that. So please make it a point to protect our maths. If you can't do it mentally, I've told you that anytime your binomial, the second term is negative, it means when you are extracting, that second factor that you have will always be what? Negative. So take note, because the binomial theorem is quoted in terms of plus. But if what you have there is minus, it means your substitution must also be minus for the second term. So take note of that. So at this point, you know your n, you know your x. You go and substitute. And when you are substituting, you know you are going to indirectly quote the formula in terms of the substitution. So you come and write therefore, or if you write implication, then you come and draw your conclusion. You know from our previous lesson, we said we'll come and draw our conclusion here, so that our conclusion will be embedded in our steps or methods. So in this case, therefore, you come and pick whatever that you were asked to expand, not the simplified or worked on version of what you were asked to expand. So therefore, this will be equal to, then you come and substitute. The first will be substitution. 1 plus, this, your n is this, your x is what you have here. So you just substitute. So n, wherever you see n, it is minus half. Wherever you see x, it is minus 2x. So just substitute that into the formula. And you can see that in our previous examples, the one that we did in our previous lesson, we ended at the term in s cubed. Here is s to the power 4, so you have one extra term. So you substitute that. After that, when you substitute, you know that your next step, which you are supposed to write equal to close to the margin. So it's like this again is equal to this. Your next step will be where you come and deal with the powers and deal with what? All that you can simplify. Especially the ones in what? In brackets. So at this point, this will give you 1. If you push the power in, this will give us what we have here. This we can simplify. You hold it like that. Now you are pushing the power in, you get this. If you want to simplify, someone can simplify this and get the x straight away. There is nothing wrong with that. But here you have to simplify this. So it will give you minus half. If you do minus half minus 1, it will give you minus 1.5. Which is the same as minus 3 on 2. Then your minus 2s squared will give you minus 2 squared, which will give you 4, then s squared. Any negative number to an odd power will give you negative, to an even power will give you positive. So you should know that this should give us a positive result. Those of you who had negative, I was wondering, because you were privy to this information. Then again, you come and simplify this. Already you've done this and this, so it's just copy and paste. We did it here. For this. So the first two factors will be the same as the next one is what you need to go and simplify. So it will be minus half minus 2. That will give you minus 2.5. So that is going to give you minus 5 on 2. So that will be the simplification of this. And you know 2 factorial is 2. 3 factorial is what? 6. Then you come and work on this one to minus 2x cubed will give you minus 2 cubed, which will give you minus 8, then s cubed. So that simplifies into what we have here. And again, you know the first 3 terms here. That will be the 3 terms here. Did I say 3 terms? 3 factors, forgive me. So you come and write this one that you need to go and simplify. So that will give you minus half minus 3. So that will give you minus 3.5, which is the same as minus 7 on 2. And if you come and deal with the power here, you are going to get, is even power. So you know that your result will be positive. So negative 2 to the power 4 will give you 16. Then s to the power 4 will give you that. Then plus ellipses. So take note, when you quote the formula without the plus ellipses, that one, you won't get B0. I'll give you, B1. But if you come and do your substitution without the plus ellipses, it will be M0 and everything will be 0. So please take note. So at this point, having pushed through your powers and also simplified all that you have in brackets, what do? The rest will basically be calculator work. Or better still, you can do it mentally. So your last step, when you are going to remove all your brackets, that will be your last step. Okay, so that would be equal to 1 plus, if I'm removing the bracket, negative will give me positive, will multiply and give me positive. The denominator 2 here will cancel the numerator 2, so I'll be left with x. And again, you use your calculator to do the whole of this. So you can do this times this over 2, then times 4. Okay, whatever that you get, you come and write it, okay, there. So in effect, you are going to get 3 over 2. I can do it mentally because I know that 2 times 2 here will give me 4. This 4 will come and be a denominator, which will cancel this numerator 4. So I will be left with 3 over what? Over 2. Okay, so that's what you write what here. Then your s squared will come. So you attach that. You come and do same here. Okay, multiply this. Okay, divide by this, then come and multiply by negative a. So you count your negative 1, 2, 3, 4. Once your negatives are even, if you multiply, you get a positive result. So, okay, that positive result will come. Positive will come. Then here 2 times 2 times 2 will give you 8. It will be a denominator which will cancel this 8. Okay, then your denominator here will be 6. So you get 3 times 5 over 6. But the 3 can also reduce the 6 and give you 2. So you rather come and get 5 over 2, which is what we have here, than your s cube. You come and do same here. 2 times 2 times 2 times 2 will give you 60. That's 2 to the power 4. That will come and be a denominator if we were supposed to do it manually. And that will cancel this numerator 16. So it means your numerator will now be 1 times 3 times 5 times 7. And your denominator will be 24. But you know that 3 can go into 24 8 times. So you cancel and you'll be left with 5 times 7 times 1. That will give you 35 then over what? Your 8. So then you bring what? Your s to the power 4. I mean, better still, you can use your calculator to do the whole of this, as I advised you in our previous lesson and even today. So that gives you our final answer A2. So please take note of the penalties. If you didn't introduce equal to here, or you use implication for this, it is M0 at this point, A0. So you only get this mark. Okay, take note of that. If you didn't draw your conclusion, or let me even put it this way, if you quoted this formula, I saw some of you do that. If you quote this formula and you just come and write equal to without writing whatever you have here, whatever you are expanding here, you cannot write this is equal to this. Immediately you write equal to here without writing this one here, it will still be M0, A0 because you are trying to say that, okay, what you have above here is what must be equal to this. Meanwhile, it is what this that must be equal to this. So the information that you want to put across is not exactly what you have here. So immediately you write equal to and something interferes. Please take note, whatever you are saying is equal to this, that step you are supposed to write it again before you come and write your equal to. If nothing interfered, if you didn't quote this formula, take note, and you quoted it mentally and you came to write this. Okay, and some of you did that. Those who didn't quote this and wrote this, you will get B2, M2 here. You won't lose any marks because this formula here is embedded in this. This is a general formula, but what you have here is a particular formula for this. So you won't lose any marks. There is maturity in this in your presentation. Only like I said, if you are not matured, you can quote this. So I'm encouraging you to quote this, and that will give you B2. I guess my point is well made. Then equal to, and take note, if you left spaces between your steps, lines, okay, between your steps, each line will be -1. Each line that you left will be -1. Remember, I've told you, you don't leave spaces between your steps unless, okay, you are moving from a sub question to another sub question. That's where you leave a line, okay, or 2. But I said 1 will be okay. All right, so at this point, take note, when you are through with your marking, indicate your score over the total score on top of your first page. I repeat, on top, not beside, on top of your first page. So it should be on top. So it will be 10. If you had 10, it will be 10 over 10. Don't just write 10. I should always see your denominator. Okay, please take note of that. Okay, so on that note, okay, so thank you very much. Okay.